298,000 miles per hour. That's how fast Voyager 1 is moving right now, as you watch this. The fastest human-made object we've ever launched, a machine we sent screaming into the void 49 years ago, powered by the dreams of an entire species desperate to touch the stars. And it's barely crawling. Right now, Voyager 1 is 25 billion miles from Earth. Sounds pretty wild, right? That little probe has traveled farther from home than any human creation in history. It's crossed into interstellar space. It's officially left our solar system. Here's what nobody tells you about that achievement. At its current speed, if Voyager 1 were somehow aimed directly at Alpha Centauri, our nearest stellar neighbor, it would take 73,000 years to get there. 73,000 years. The entire recorded history of human civilization is only about 6,000 years old. Subscribe to the channel for more space videos, because what you're about to discover will mess with how you see humanity's future among the stars. But here's the thing that should terrify you. Voyager 1 is our absolute best shot. Everything we knew about rocketry and physics packed into one machine, and it's moving at a pace that makes a snail look like a race car once you start talking about interstellar distances. The problem isn't just speed, it's something much worse. Number 1, the wall of distance. Picture the most isolated place you've ever been. Maybe you were hiking alone on a mountain trail, miles from the nearest road. Maybe you were in a small plane over an endless ocean, looking down at nothing but water in every direction. Now multiply that isolation by a number so large it breaks your brain. Alpha Centauri is 4.37 light years away. That means if you could somehow travel at the speed of light, which is physically impossible for anything with mass, it would still take you 4 years and 4 months to get there. But here's what makes scientists lie awake at night. Light travels at 670 million miles per hour. Our fastest rockets, the ones that carried humans to the moon, topped out at about 25,000 miles per hour. That's not 1% of light speed. That's not even 1/10 of 1%. The space between stars isn't empty highway. It's an ocean of nothing so vast that our fastest ships would take 70,000 years to cross it. Launch today and arrive in the year 75,026. The pyramids of Egypt would be older to us right now than our current civilization would be to those future travelers. But distance? That's just problem number 1. Number 2, the energy nightmare. There's a rocket scientist at NASA named Dr. Sarah Chen who keeps a simple calculation on her whiteboard. She calls it the reality check equation. Here's what it says. To accelerate just 1 pound of matter to 10% of light speed, you'd need more energy than the entire United States produces in a year. 1 pound, 10% of light speed. A spacecraft capable of carrying humans to another star would weigh thousands of pounds. The life support systems alone would be heavier than the International Space Station. The fuel tanks would be the size of skyscrapers. You'd need to capture the entire energy output of the sun for months just to reach a fraction of the speeds you'd need. There's a concept in physics called the tyranny of the rocket equation. Every pound of cargo requires fuel, but fuel has weight. So now you need more fuel to carry the fuel, which means you need even more fuel to carry that fuel. The math spirals into impossibility so fast it makes your head spin. Some scientists have proposed fusion rockets. Others talk about antimatter engines. Sounds promising, right? Here's the catch. We've never built a fusion rocket that works, and antimatter costs about $62 trillion per gram to produce. You'd need tons of it. The energy problem isn't just hard to solve. With our current understanding of physics, it might be completely impossible. But let's say we somehow crack the energy equation. Let's say we build a ship that can actually reach 10 or 20% of light speed. Now we're looking at a different nightmare entirely. Number 3, keeping humans alive. Dr. Lisa Park spent 15 years studying what happens to the human body during long spaceflight. She worked with astronauts who'd spent a year on the International Space Station. These were the toughest, most physically fit humans on the planet. They came back with bone density loss, muscle atrophy, vision problems, and psychological trauma. That was 1 year, 250 miles above Earth, with constant communication with mission control, with the ability to look down and see home. A journey to Alpha Centauri, even with a miracle engine, would take decades. The astronauts who left Earth would not be the same people who arrived. Their children, born in the void between stars, would never see a sunrise, never feel rain, never breathe air that didn't come from a recycling system. The psychological studies are terrifying. Isolation, confinement, and the knowledge that Earth is just a distant dot of light has broken test subjects in simulated missions lasting just months. Now imagine that feeling for 20, 30, or 50 years. The life support systems would need to work perfectly for decades. No failures, no breakdowns. One critical malfunction and everyone dies, billions of miles from any possibility of rescue. The International Space Station, our most advanced life support technology, requires constant resupply missions from Earth and regular repairs by spacewalking astronauts. There would be no resupply missions to Alpha Centauri, no spare parts, no way home. But the technical challenges, they're nothing compared to what's waiting for them out there. Number 4, the killing void. Space isn't empty. It's filled with things that want to destroy you. Cosmic radiation streams through the galaxy at nearly light speed. On Earth, we're protected by our magnetic field and atmosphere. In deep space, that radiation would slowly cook anyone exposed to it. The cancer rates would be off the charts. DNA damage would accumulate over decades of exposure. Then there are the micrometeoroids, tiny pieces of space debris, some no bigger than grains of sand, traveling at tens of thousands of miles per hour. At those speeds, a fleck of paint can punch through metal. A grain of sand hits like a bullet. The Voyager probes have been battered by thousands of these impacts over the decades. They're still functioning, but they're machines. Humans are much more fragile. And here's what keeps mission planners awake at night. At interstellar distances, a single catastrophic failure means certain death for everyone on board. No rescue mission could ever reach them. No spare parts could be delivered. They'd be completely, utterly alone. The crew of Apollo 13 nearly died after an oxygen tank exploded, and they were only 3 days from Earth. Mission Control worked around the clock to bring them home. In interstellar space, you'd be years away from any help at all. So here's the real question. When will we actually reach another star system? The honest answer is brutal. With current technology, never. Chemical rockets are too slow. Nuclear rockets don't exist yet. Fusion engines are theoretical. Antimatter engines are science fiction. But let's be optimistic. Let's assume we solve the energy problem in the next 50 years. Let's assume we develop fusion engines or some form of advanced propulsion we haven't even imagined yet. Let's assume we figure out how to keep humans alive and sane during decades-long journeys through the void. Even then, the first human mission to another star system probably won't launch until the 22nd century, and it won't arrive until the 23rd century or later. That's assuming everything goes perfectly, assuming we make breakthrough after breakthrough in physics, engineering, life support, and psychology, assuming we don't destroy ourselves first. The more likely scenario, the first humans to reach another star system haven't been born yet. Their great-grandparents haven't been born yet. Here's what makes this especially sobering in 2026. We're living through what feels like the golden age of space exploration. Private companies are launching rockets every week. We're planning missions to Mars. We're building lunar bases. Space feels closer than ever. But Mars is a day trip compared to the stars. The moon is in our backyard. Even the outer planets of our solar system are local destinations compared to the vast emptiness between us and Alpha Centauri. The universe is unimaginably huge. The distances crush human intuition. The energy requirements dwarf our entire civilization's power output. The dangers are so numerous and so deadly that a single mistake means everyone dies. But here's the thing about humans. We've never let impossible odds stop us before. 500 years ago, crossing an ocean seemed like a journey into the unknown that might kill you. 150 years ago, human flight was fantasy. 70 years ago, reaching the moon was science fiction. Every time, the problems seemed insurmountable. Every time, the distances seemed too vast. Every time, the energy requirements seemed impossible. And every time, we figured it out. Maybe the humans who finally leave our solar system will use technology we can't even imagine today. Maybe they'll find ways to bend space and time that make our current rockets look like stone tools. Maybe they'll discover that the universe has shortcuts we haven't found yet. Or maybe they'll just be willing to take a journey that lasts longer than entire civilizations. Maybe they'll build ships that are less like vehicles and more like traveling worlds. Maybe they'll accept that the people who leave Earth won't be the ones who arrive. The question isn't whether humans will ever leave our solar system. The question is whether we'll still be human once we finally do. Subscribe to the channel for more space videos.